Welcome to Across the Globe. Today we will learn about classes and objects in Python. Classes in Python serve as templates for creating objects by defining both the data and functionality that the objects will possess. Objects are individual instances of classes that can store data specific to that object, attributes, and perform actions, methods. By creating a class, you can quickly generate multiple objects with similar characteristics and behaviors. For example, a car class could have attributes such as color and model, along with methods like drive and stop. When an object is created from a class, it is referred to as an instance of that class. This allows for versatility and reusability in programming. An object based on the person class might have attributes such as name and age, as well as methods like eat and sleep. Classes and objects are integral to object-oriented programming in Python, facilitating the organization and management of complex data structures and operations. To create a class in Python, utilize the class keyword followed by the class name. Within the class, attributes, variables, and methods functions can be defined. In the provided example, the class dog is created with attributes name and age, defined within the init method. Additionally, the bark method returns the string woof when called. This class structure is crucial for organizing similar objects and behaviors. When creating an object from a class in Python, you call the class as if it were a function. By doing so, you instantiate an object of that class. Subsequently, you can access the object's attributes and methods using dot notation. For example, given a class dog with attributes name and age, you can create an object mydog equals dog Fido3 and then access its attributes and methods like mydog.name or mydog.bark. This approach provides a convenient way to interact with the objects instantiated from classes. Inheritance in object-oriented programming allows one class, known as the child class, to inherit attributes and methods from another class, known as the parent class. In the provided example, the class Labrador is the child class that inherits from the dog class, which is the parent class. This means that the Labrador class can utilize attributes and methods defined in the dog class. For instance, the Labrador class can access the fetch method defined in the dog class. This enables Labrador instances, like the myLabrador instance in the example, to perform actions such as fetching a ball. When myLabrador.fetch is called, it returns the message, I fetched the ball, because the fetch method is inherited from the dog class. In summary, inheritance allows for the reusability of code and promotes a hierarchical structure in class relationships, facilitating the building of more complex and specialized classes based on existing ones. Classes in Python are like blueprints for building houses, defining the layout and structure of the house. Objects are like individual houses built from a blueprint, each having its own unique characteristics and functionalities. In a program, a class for a car may define attributes like color, make, and model, as well as methods like start engine and accelerate. Objects of this car class can then be created, each representing a different car with its own set of attributes and abilities. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. In the provided Python code snippet, a class named car is defined. This class represents a car object with attributes such as color, make, model, and a method to start the engine and accelerate. The class has an init method, which is a constructor method used to initialize the object with the specified color, make, and model. It also initializes the engine started attribute as false. The class contains two methods. One, start engine. This method sets the engine started attribute to true and prints a message indicating that the engine of the car has been started. 2. Accelerate. This method takes a speed parameter and checks if the engine is started. If the engine is started, it prints a message indicating that the car is accelerating at the specified speed. If the engine is not started, it prompts the user to start the engine first. Two instances of the car class, car1 and car2, are created with different color, make, and model combinations. The objects, car instances, are then interacted with by starting the engine and accelerating. The output displays messages confirming the engine's start and acceleration of the cars based on the actions performed on the objects. In a real-world scenario, these classes and objects can be utilized in a simulation of a car rental service where each car object represents a rental car with specific characteristics. The methods in the class can be used to simulate actions like starting the car or driving at different speeds. One industrial application of using classes and objects in Python is in simulation software for autonomous vehicles. By defining classes for vehicles with attributes such as speed, position, and sensor data, developers can create realistic simulations to test the performance of autonomous systems in various scenarios. In the field of e-commerce, classes and objects are utilized to model products and orders. Each product can be represented by a class with attributes like name, price, and description, while orders can be instances of a separate class that contains information such as the products purchased, total cost, and shipping details. This object-oriented approach helps in managing and organizing the vast amounts of data involved in online retail transactions effectively. Across the globe, embracing object-oriented programming principles in real-world applications enhances modularity, efficiency, and scalability, making it a fundamental aspect of software development across diverse industries. Keep learning, stay curious, and I'll catch you in the next video.